All right. Welcome back. This is now day 2 of 8.1.1. I've actually tried to record this a couple times and I've had to restart a bunch of times. So hopefully I can do it right this time. Today we're going to be talking about which tool is more precise. If you remember from yesterday, we measured the length of the classroom along the window wall and found out that we used that with a tape measure and with a 12-inch ruler. The 12-inch ruler was like a normal ruler. The tape measure was 120 inches long. And we want to see which one is the more precise tool. So after looking at this data yesterday, looked like this, we were able to find the range, median, and the quartiles for each of these numbers, which is probably setting us up to do some box plot stuff and maybe some stuff with bar graphs, or histograms. So that's what we're going to do right now. Before we do that, let's check our homework and kind of go over what's going on in the homework. So from your homework, and I'm just going to kind of let you look at this, and I might talk about a few. If you need to pause and make sure your work is right. That's important, especially with me not being there to be able to answer any questions. So this was 8.8, where they asked you to make a stem and leaf plot, and I circled my median because they asked me about the median. And then my quartiles were the middle of these, of the upper half and the lower half, which happen at these two numbers, the middle of each upper and lower half. This should say Q3, by the way, not Q2, my fault. 8, 9, here are the answers for A, B, C, and D. You should do this without a calculator. Problem 810, remember you can pause this anytime you want. 810A, I got x equal to 1, and B, I got x equal to -2. Problem 811 was a 5D problem where they wanted you to write an equation. I started off with this, with the short side as the one that I'm guessing. And they told us that these two sides were equal. So the short side and the other short side were both x. The third side was x plus 12, and the fourth side was 3x minus 9. Their perimeters, when you add them all together, equal 117. So if you add this plus this plus this plus this, you get 117. A simpler way to call all of this is 6x plus 3 equals 117. And if you solve it with algebra, you get x equal to 19. When you plug 19 here and 19 there and 19 plus 12 and 3 times 19 minus 9, you get these sides that you see in my sentence answer. Problem 812, they wanted you to fill in a table for a number of taffy pieces and the cost in dollars. 4 pieces were 25 cents each. So I had y equals 0.25x, where x is the number of groups of 4 pieces, I guess is the way we're going to do that. I'm not sure if I agree with this answer that I wrote earlier, so I might be coming back to that one. Anyway, I'm going to go ahead and put that back, and we're moving on. Problem 8.5. So this actually, there's a resource page that's in your Google Classroom. You can print that out, and then you can follow along here if you want, or you can just watch the video and then do the work later. So part A, make a histogram of each set of data. So using yesterday's data, they want us to make a histogram of the tape measure data and the ruler data. And I think what we'll use is a bin of 5, because we're trying to go from 312 to 346. So let's go from like 310 to 350 using bins of 5. So if I do that, let's say this is going to be 310, 315, 320, 325, 330, 35, 40, 45, 50, and we're going to do the same here because they asked us to use the same scale for both histograms. So this will be my 310, 320, 330, 340, and 350 inches. Those are the width of the room in inches. Inches. Okay. Now, I've already kind of pre-looked at the answers. So on the frequency side, I'm going to count by twos. I'm going to call this 2, 4, 6, 8, 10, 12, 14, 16, 18. And I'll do the same here. 2, 4, 6, 8, 10, 12, 14, 16, and 18 measurements. We had 22 total, so since we don't have to go that high, then we can start here. So looking at the data from on the ruler data, let's start there since that had the lowest number. 312 would be part of the 310 bin, 310 to 315. These would be part of 315 to 320 because it starts at 315 and goes up to just before 320. 320 will be the next bin. So if I had to put in a couple of bars already, this would go in the first bar, the first bin, this would go in the second bin. So going over here, from 310, there's 1 in that bin for the rulers, and there were 2 in the next bin. From 320, 1, 2, 3 before 325. So the next one will be 3. Remember, I am counting by twos. Here's 2, here's 3 about in the middle. Going on. From 325 to 330, I have 1, 2. These are in the next group, so just 2. From 330 to 335, I have 1, 2, 3, 4, 5. That'll be the next bin. So I need a bar of 5. 4 and 5 is the middle. And then for 335, I have 1, 2, 3, because 340 is the next bin. 2, 3. 340 to 345 is going to be 1, 2, 3, 4. That'll be the next bin. 1, 2, 4. And then 345 to 350 is going to be these 2, just 2. So we're going to have a little 2 bar. It's kind of spread out pretty evenly with 1 peak. That's almost the second peak though. We have 1 peak. Now on the, so this one we're going to put as the ruler data. And this will be the tape measure data. And in the tape measure data, we got to start around 330. So from 330 to 335 is 1, 2, 3, because that's the next bin. So 330 to 335 is 3. And from 340 to 335 to 340, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's the next bin, 14. So I got to go 2, 4, 6, 8, 10, 12, 14 high. And then 340 to 345, I'm going 1, 2, 3, 4. And the last one will be 2, 4 and 2. So 1, 2, 3, oops, sorry, 2, 4. And the last one would be in the group 2 because 345, 3 to 46 would be in that group. All right, so now we've got our histograms. Again, 1 peak and pretty evenly spread out, but it's a tighter cluster of data compared to this. This is really spread out. Problem B. Create box plots for the 2 sets of data. Put both box plots on the same number line. So we're going to have to go back and check out our median and quartiles for the ruler. So from the ruler data, we had a median of 334 and quartiles of 324 and 340. Remember those numbers. So we had a median of 334, and this one was, see, I'm an old man, I already forgot, 324 and 340. So this is 324, 340. On the tape measure data, we had a median of 337 and then 336 and 339. So let's see, 337, 336, and 339 inches. They ask us in the thing to put both box plots on the same number line and use the same scale that we did for the histogram. So if I call this 310, 15, 20, 30, 40, 50, these are going to be kind of close and small little box plots. So let's do the ruler data on top here. So that started with a low of 324, lower quartile about, and I'll put it up here kind of high. There's the quartile 1, a median at 334. We'll put that one about here too. And then a upper quartile at 340. And I think if I remember right, the lowest extreme will be at 312 and the upper will be at 346. So at 312, we'll put a little mark. And at 346, we'll put a little mark. And these will be the whiskers. And we'll call this ruler. Now the tape measure median. The median is at 337. Here's 35. Here's about 37, let's say. The lower quartile is at 336. Wow, those are close. The upper quartile is at 339. So this makes the box of the box plot. And then when I go look at the extremes, the lower extreme and the upper extreme are at 330 and 341. So 330 would be here, and 341 might be about here. So that is a very tight box plot for the tape measure. So interestingly though, the medians are kind of near each other. They're not that far away. They're only looks like about 3 units away, 3 inches away from each other. So we can now answer some questions about this. Compare the center, shape, spread, and outliers for these 2 sets of data using histograms and box plots. Do the data sets seem to show the same value for the length of the classroom? All right, so let's see if we can answer this. Looking at those graphs, and I'm going to kind of type it in here. The center of the ruler data is around, let's see, what was it around? The center was around, was that there, 334. Where the tape measure was around 337. So was around 334 inches where the tape measure center was 337 inches. Both graphs were pretty evenly spread. Both graphs had only one peak and were fairly symmetric. So if I go back here and look at this graph, when I say symmetric, in the histograms, you can kind of see that they kind of go up and down together. This is our symmetry. There's an up and a down together with one peak in it. And there's no numbers way out here and there's no numbers way down here. It's very symmetric around the center. The spread of the data is what's different. So let's take a look at that. You can see in the box plots here that the spread of the tape measure data is very small. The interquartile range is only going to be 4 inches for the tape measure, where it's 16 inches for the ruler. So the ruler data is very spread out. In fact, I wouldn't even call this an outlier because the spread is so wide. You might call the 330 an outlier because the spread is so skinny. So let's see what we can add to this here. So we talked about that. We talked about the symmetry. Neither graph shows outliers away from the data set, but the tape measure data might have 330 inches as an outlier because the variability of the data is small. The interquartile range is only 4 inches. That means most people measured about the same number with the tape measure. I would say that if I had to pick a measurement for this room, I might say somewhere between 334 and 337 because the medians were so close. So the measure of the room might be between 334 and 337 inches, since the medians were so close. Okay, so that's how these graphs help us make an analysis of the data. I know it's a lot, so pause and rewind and read it and listen to what I'm saying and see if you can figure out how this works. Okay, moving on here. Which measurement is best? So what is the actual measure? Clearly, you have multiple measurements from which to choose. How can you decide the best estimate? Look at the data set of each tool, along with the histograms, box plots. Consider the center, the shape, the spread, the outliers. With your team, discuss what you've learned from each of these pieces of information about the precision or consistency of each measuring tool, as well as about the length of the classroom. Which of the many numbers do you could you choose? Which of the main numbers that you could choose is the best estimate of the actual length in the classroom, and why? What do you think accounts for the greater consistency of one tool? All right, so that's a lot of question right there. I think what they're really getting at is that since the medians were so close, since the data was so evenly spread, I would say that the actual measurement of the room is near 336 inches. So you could put that down as an answer. Kind of like what I answered before. The actual length of the room is near 336 inches because the data, the medians, were close and the data was evenly spread out, evenly spread. They ask you about the consistency of one tool over another. I would say, and I'm going to maybe put this up as a little separate comment up here. Let's put a little text box right here to answer that question. The tape measure data was more consistent as shown by the large peak in its histogram. If I had to pick why that is, I might say something like, well, when you're measuring with that tape measure, you can measure longer spans at the same time, like at once. So you have less chance of making cumulative errors in between the measurements. And that should give you a better answer. Let's go on to 8.7. Is measurement always approximate? As you've seen, the measurements that you made are approximate. Is this always true? Can you imagine a way to measure something that would be exact without any variability? Discuss this with your team and be prepared to share your ideas with the class. I don't know if we can ever get an exact measurement, but we should be able to get close and maybe take an average of all those answers, and we can say that that is a very close approximation. But since nothing can actually be exact measures, there's always some form of error in the calculation. If we wanted to get really close, we could have a tape measure that's as long as the whole classroom, and I bet you everybody's going to get within the same inch, or maybe even closer to the same number, like half inch. So I think it just depends on the measurement tool, how close our answers will be together when we're doing that. So can you imagine a way to measure something that would be exact? No, not exact, but we're getting closer and closer with digital measuring tools or laser measuring tools and things like that. So you can put down an answer for yourself for 8.7. And then we're going to go on. You can pause if you need time. Your homework tonight is going to be 8.13 to 8.18. Work hard, and we'll check it tomorrow.